Hi, welcome to StarWind software. Today we're going to talk about shared storage for the SMB using StarWind software. Our topic for today is DAS to SAN. Our agenda is going to be an overview of SAN technology. We'll take a look at the traditional fiber channel SAN. We'll look at an iSCSI SAN. We'll compare some advantages and disadvantages of direct attached storage versus SAN technology. We'll look at why we want to go with iSCSI. We'll look at some application advantages of shared storage with a SQL Exchange server and virtualization. Then we'll start building a HA set with a live demo. We'll look at the configuration of hardware and software and look at some enterprise class features that we offer. This is our traditional fiber channel SAN. As you can see, we have fiber channel cards, which are really expensive. We need, for the fiber channel cards and the fiber channel switch, we need our fiber channel infrastructure. So that's something that you need to put in place as well. The fiber channel SAN you'll also need fiber channel disk drives. Well, this type of a system does have some pretty good performance. There's no need to consider a more cost-effective alternative to fiber channel, which when set up correctly will deliver the same performance results. Here is our iSCSI SAN. We have our same application servers. We've replaced the fiber channel HBAs with standard 1 gigabit network adapters. We're using your existing Cat5 network or wiring that's within your organization already. And we're using our standard 1 gigabit Ethernet switches. And for our storage, we have repurposed two x86 servers to work, to work as our storage servers. Bandwidth scalability can be increased by adding more NIC cards to our application layer and also to our storage host. And you can also expand your storage by adding more drives to these boxes or adding more servers, whichever you prefer. Now with DAS, the application servers would use the local disk to store the data. As the amount of data grows, the disk space must grow, but a lot of times we find that due to the physical limitations of the chassis, we cannot add any more disk drives to them. And also the servers need to be shut down to add any additional disks. Another problem with DAS is that when you have disks and tape drives directly attached to the servers, they cannot be used by other systems, leading to an ineffective use of the hardware resources. So a lot of businesses have found that they have to purchase more storage capacity, even though free capacity is available in other platforms. You can actually share the data, but when you you need to access the service to do so. So if someone is doing some heavy read or writes, it can have a great impact on the performance of the application running on the server. So SAN technology. The users are connected directly to the shared storage. It's great for moving large blocks of data. You can centralize the management of your storage resources. You can provide data level protection. You can mirror the volumes at the block level. You can have volume-based snapshots. And you can unlock some enterprise application features with virtualization, with VMware, Hyper-V, Xen. And you can also provide shared storage for Windows clustering, SQL Exchange, or Oracle. So why iSCSI? iSCSI is an interoperable and universal standard with non-proprietary technology. It's been around for over 30 years. It works over your existing Ethernet network, and it will allow you guys to use your existing and standard equipment. So there's no need to go out and buy new switches or routers or add any more Ethernet, wiring in your organization. As long as you have Cat5, you're good to go. Our StarWind software works on any x86 server, 64 or 32-bit, and we can convert any server into a centralized network storage for any application. It's reliable, scalable, fast, and affordable. So here's our SQL Server or Exchange cluster, and right here. And we also have a couple of storage nodes. They can be either active passive, which is our grade 1 mirroring. So when you write to our active node, the data block is immediately written to the passive node, so that a warm copy is stored on your passive node. So in the event that you lose your active storage, you just need to point your iSCSI initiators to the passive storage box, and you can have access to your data again. Or you can also configure these as our HA, or high available data stores, where they take turns talking to the SAN in a round-robin type of deal. So when you write your data to storage 1, it is then passed over to storage 2, and when you write data to storage 2, it's passed over to storage 1. Now your SQL Server or Exchange servers are protected by Windows clustering. So if one of these nodes fail, the other node will take over. With virtualization, again, we'd rather use our high available feature with our virtualization. And you can also have volume-based snapshots and network-based mirrors. And again, we're still using your existing Ethernet network with a 1 gigabit switch. We have our VMware host, which can be running vMotion, storage vMotion, or high availability. We have our users connected to the corporate LAN, and they're accessing the data that is on the, or they're actually accessing the applications that are running on these servers. So you can have improved application availability with no loss in application performance, and it's also an easier or more effective use of your IT budget. So now we're going to build this in and go into our live demo. So this is our StarWind management console. And from here you can actually access all of your StarWind servers. I'm actually logged into just 2 of these right now, but you can log into as many as you wish. So we're going to create our high available data store. So you can right click on targets, or actually click on add target up here. So we're just going to select here and add a target. We'll give it a name. Demo September 23. Click Next. Some of the options we have is a hard drive option where you can export a physical or create a virtual hard disk device. Our optical drive option, you can export or create a virtual optical drive. And our tape device, which will let you export any physical or create a virtualized tape drive, thereby reducing backup costs. Physical hard drive here is used when you decide to create centralized storage using your existing hard drive or RAID arrays, which also can be used for disaster recovery or backups. We have our basic virtual, which is similar to a Windows hard disk. And we have our advanced virtual, which will unlock some of our some of our more advanced features. So within the advanced features, we have our mirroring or RAID 1, which is our active passive mode, snapshots and continuous data protection. So in the event that someone during the day deletes or removes a file or folder, you can mount a snapshot and restore the file or folders. We also have our high availability device, or HA, so that in the event that one drive fails or one storage service fails, the other will take over. So now we're going to click Next. Now we want to know who our partner host is. So you want to just put in the IP address. In this case, it's 192.168.10.12. The default login is root, and the default password is StarWind. And you can change that to whatever you like. Now, on the partner server, it's going to create a partner device and give it the same name and just add partner to the end. So now we want to create our virtual disk parameters. So we just want to navigate to a place to store it. The demo folder is a good place for me. So you just want to give it a name, Demo September 23. Click OK. We're going to create a new one. And on our partner server, we're going to do the same thing. Just give it a name, Demo September 23. Click OK. Create a new. And we'll just make this 1 gigabyte for, for demo purposes. Now we want to know what our data synchronization channel is going to be. The data synchronization channel is our link between our two HA servers. This is where the data is passed through from one server to another. So when you write to our primary server, it's then written to the secondary server. You should have a dedicated NIC for this and go point to point. And it's even better if you can bond two NICs in a active backup. So that, in the event that one of the NIC cards fail, the other one will take over. On these servers, I just have one interface connected. So I'm just going to choose these two. They're still in the same network. And we also have selected auto synchronization after fail, so that in the event that one of our servers goes down and comes back up later on, it'll automatically perform a synchronization. So now we click Next. Some of the options we have are we can clear our virtual disk. We can synchronize the partner server with the current one, or you can synchronize the current server with the partner. If you're creating a new device, you don't need to check this. For now, we're just going to select Do Not Synchronize the Virtual Disk. Another reason why you may want to choose the Do Not Synchronize the Virtual Disk is if you're remounting an HA image. You may not want to synchronize right away. So these are our cache options. We have write-through caching. What write-through caching does is as you write data to the disk, it stores it in RAM and also writes it to the hard drive. So this way, if you're going to do another read with that data, the read will happen much faster since it's already in RAM. Write-back caching, when you write data to the server, it stores it in RAM and sends an acknowledgement that, yes, I got the data, and so the other servers can send more data. The only issue with write-back caching is that your data is stored in RAM for a little bit of time. So if you're going to use it, have a UPS with some sort of power chute technology for a clean shutdown in case of a power failure. In any event, if you choose caching, you should give it some size. I usually recommend at least 1 gig if you're going to do it. And you can also change the amount of time, which is the expiry period, that your data is held in RAM. So now we can verify our parameters, if you wish, and click Next to finish. So it just takes a couple of seconds here. And we're almost done. Let's see, maybe it's just not taking the click. Alright, here we go. So here's our primary target, which is the demo September 23rd. Our partner target hasn't shown up yet, but we can always do a refresh. And it's here. Here's our partner's device. I'm going to expand this window. And we can look at some of the parameters, or the device parameters. So currently they're synchronized between our current server and our partner server. And they're ready, and they're also set for auto synchronization after failure. So now we can take our iSCSI initiator and connect to our server. I'm just going to remove this and re-add it. You enter in your IP address, click OK. We can go to Targets, do a refresh. You can highlight this and click Log On. One of the things that you may want to do is check off the automatically restore this connection when the computer restarts. If you're live and you're in production, you probably want to do this in case one of your computer fails. And if you're going to use clustering, you should enable multipathing. For the demo, and for my laptop, I'm not going to do this. So we're just going to log on, and it shows us being connected. So now we can go into our admin tools, computer management. And disk management. We can select our new disk and initialize it. Now you can select either the master boot record or the GUID partition table, whichever you prefer. And then we will create a new simple volume. And generally I just go through the wizard, perform a quick format, and we'll just name this demo. So as soon as this is finished formatting, we're ready to go. We can just start copying data to it. That looks like it's done formatting. We can get rid of this. Actually, we don't need this. Now we can go to our Windows Explorer. And here's our demo. And we can start copying some data to it. And it's that simple. So you can go to our website and just download our software. We have a 30-day demo that you can download. Go through the wizard and install the software. Configure your disk stores. Select your virtual disk device. Connect to your new SAN. So some of the enterprise class features is continuous data protection and snapshots, where you can have an instant point-in-time technology where you can recover individual files or folders or roll back an entire volume to a single to a point prior to failure. We have mirror and replication, which is our asynchronous replication. And you can also synchronize your mirrors across the LAN. It's our software grade 1. And we also offer thin provisioning so that you don't have to go out now to buy all your hardware. If you know you're going to grow your system to, say, 10 terabytes next year, or you know only this year you're going to use about 4, you can just buy your 4 terabytes of disk now, over-allocate them with thin provisioning, and as you need them, you need more disk space, you can add the drives to your disk stores. So with StarWind software, it's an iSCSI software solution. It's reliable. It offers rock solid reliability. It's scalable. You can add storage. You can increase your bandwidth, and it's also affordable. So you can go to our website, www.starwindsoftware.com, download our 30-day free trial, give it a try. Or if you have any questions, you can call us at 617-449-7717, or you can email us at sales@starwindsoftware.com. Thank you for your time, and I hope you got something out of this webinar.